Welcome to the Skill Talk to Struck podcast, where we dive into the world of innovation and technology. My name is Malika, and I am the CEO and founder of Skill Torch, which is a recruitment company operating in the AI space across the globe. Today, I have with me Ron Picard, who is the Director of Autonomy Engineering. He's here to talk to us a bit more about AI in action and also navigating the skies when it comes to AI and autonomous robotics. So, Ron, great to have you here.
Awesome. Thank you so much. Yeah, my name is Ron Picard. I'm the director of autonomy engineering for a small defense contractor named Epici. We specialize in building autonomy and AI software to basically control robotic systems. Think of especially aviation systems like small quadcopters all the way up to large like F16, fighter jets. Um, my background is a prior Air Force civil servant before I took this job, where I did a lot of autonomy and AI engineering across the country with a lot of different agencies. That culminated in being able to put AI dogfighting agents on an F-16 and basically having it do Maverick Top Gun style maneuvers in the air. So kind of a wide breadth of experience, and happy to be here.
Great. So what sort of how did you sort of get started in that industry? That's pretty cool actually.
Yeah, that's funny. Let's see. I started in software engineering a little bit in college. My graduate was in undergraduate mechanical engineering, and I decided that I did not have a passion for doing that. I had more of a passion for doing, software engineering. So I started, kind of teaching myself to program on the side. Ended up landing a software engineering job in the Intel community. And then I had a buddy of mine who was an Air Force civil servant at the time, getting ready to kick off an autonomy effort in early 2017. This might have even been late 2016. We were chatting at a birthday party for a friend, and he was like, "Hey, I need a software engineer on my team." And I was like, "Hey, this sounds like a pretty fun opportunity." And so I jumped, out of the current job that I had at that time was as a defense contractor into civil servant work for the government, and kind of the rest is history. Been doing autonomy engineering ever since then, leading large programs.
Nice. And then what about Epi side then? How did you get started in this company that you're at?
So funny enough, this company was one of the companies developing AI agents for the F-16 that was under my portfolio when I was in the government. So,
Wow.
um, I basically funded the development of this platform and the maturation of this platform called the X-62 Vista at Air Force Test Pilot School. And at the same time, I was trying to partner with different organizations and companies to, get their AI agents onto this aircraft to, start the testing of advanced AI technologies. And FSI was one of those companies that DARPA ACE, DARPA is a big defense research agency. Uh, they had a program called, DARPA ACE, which is all about AI dogfighting and simulation. So I called up the program manager and was like, "Hey, some of your performers, including Epici, I think they'd be great to come, test on this asset." And so, we kicked it off. I think this was uh, early 2022, and then by the end of 2022, uh, or actually early 2021, I think by the end of 2022, somewhere in that time frame, we had our first live AI agent controlling a fighter jet and doing dogfighting maneuvering. So
Oh,
yeah.
amazing. Okay, then talking about just sort of like the AI technology, how do you sort of feel it's involved within the defense sector, especially when it comes to like autonomous systems like aircrafts and about drones? I mean, I do quite a few for these podcasts. I don't really have people talking about drones and aircraft, so I'm pretty curious about it.
Yeah, it's super fun. The technology's matured incredibly over the last like 8, 9 years I've been doing this. I would say, for a lot of years, the autonomy, if I say that in air quotes, that we had on different aircraft in the DoD were basically, simple intelligence, surveillance, and reconnaissance drones that just kind of just flew around and did a small little loiter. Nothing intense aerodynamically, things that weren't incredibly challenging for the aircraft to do at a decision making level. It's kind of just like fly here, fly there, look with your sensor this way, look with your sensor that way. And over 7 years, as the technology has changed, as computers have become more and more computationally advanced, people have started to apply more bleeding edge techniques to autonomous aircraft to
Mhm.
where we're, at this point we're flying, deep reinforcement learned neural networks on these aircraft and having them do more and more advanced capability. How fast you make a decision when you are MQ9, for instance, flying a loiter is a very long decision loop. Like you don't have to make your decisions very quickly. If you're flying a fighter jet and you're doing 1v1 dogfighting with guns only, you have to make decisions rapidly, multiple times a second to adjust, not only your energy state, but also like your positioning to ensure that you get a competitive advantage against a red asset. And so, the technology has evolved where we're applying these modern techniques to really close those loops faster and do more advanced decision making in the air.
Very cool. You did a article, didn't you, which sort of highlighted
Yep.
AI fighting on the F-16 fighter jets. Can you sort of give our listeners sort of a brief overview of that accomplishment and sort of your significance and yeah, basically what happened there?
Yeah. So that's along the lines of that DARPA ACE stuff. Those weren't the only performers that we had. We had a few performers. It was EPISI, Shield AI, and Physics AI. And we also had a Air Force Research Laboratory group called ACO. I think it's Advanced Autonomous Air Combat
Hmm.
operations, and we had them come out as well and integrated all of the software onto the F16 that's been modified that we had spent probably 2 years, 3 years modifying at this point. And my job was both as a program manager and a technical designer for the aircraft, and then a selector for the autonomy agents that were going to go in there. So kind of overseeing the entire effort. So I oversaw what computers were going to go in the aircraft and helped some of my other colleagues who even now work at EPISI, including Dr. Chris Cotting, who was kind of leading the technical effort at Test Pilot School at the time, and then Matt Nemec, who was my colleague and my Air Force organization, both kind of working it together, designing, the internal specs of the vehicle, essentially like the interfaces that we were going to control the vehicle through for the autonomy agents, where the autonomy agents were going to sit. And then once we got the agents in, we kind of decided what we wanted them to do. We wanted, ACO to do beyond visual range engagement, basically like if you can't see the person with your physical eyes, it's considered, beyond visual range. We wanted them to test out those type of algorithms. And for DARPA ACE, it was all within visual range. So if you can see with your physical eye the other asset, that means you're close enough to call your engagement within visual range. So we tested a wide variety of algorithms and culminated in the releasing of that, press release. Again, I think that was like late 2022, potentially. We're in 2024 now. So really exciting time. It was a lot of work to get there across multiple organizations, Air Force Research Laboratory, Air Force Test Pilot School, DARPA, and then multiple industry performers, as well on the hardware side, Lockheed and Calspan. Yeah, kind of all across the board.
Amazing. Oh, it's so yeah, that's really, really super cool. So when it sort of comes to sort of the AI robotic systems, then what, in your sort of opinion, is the right blend of techniques to sort of ensure safety and effectiveness?
Yeah, that's something we've learned over time. So if you ask classical aero controls engineers who have built airplanes since, early 1900s, they will use basically these classical control techniques,
Mm.
PID controllers, and things that are very well understood with certain bounded guarantees. However, they don't help you in the decision making that much that a pilot would have to do. I'm a private pilot, and at a very
Oh,
small
oh,
level,
cool.
yeah, yeah, at a very small level, I have an understanding of aeronautical decision making skills that are required when you're, piloting when you're in command of a cockpit. There's a lot of little things you have to make up for, and classical controls don't necessarily give you all of those answers. That's where modern AI techniques like deep reinforcement learning come in because they help you make actual decisions about what you should do in the air in a concrete way. However, it doesn't necessarily make sense to take, you know, uh, full deep reinforcement learning and replace the guarantees that we had on classical controls. So what we do at EPISI and what I have discovered even in my time in the government was that if you try to make AI do everything, even control the ailerons of an aircraft, it just doesn't do it very well in live flight. It can't handle wind conditions super well. You spend hours and hours trying to train and retrain the algorithm and then train it over again because you find some new condition that doesn't work super well that a classic PID controller can kind of solve. Now, at the end of the day, you probably could do it, but you're really wasting compute resources for a suboptimal solution. So what we've done is started to combine those techniques together, where you have, classic controls and optimization algorithms doing what they're really good at. And then you have AI doing what it's really good at, which is those really hard decision-making problems where you're not really sure how to write a classic algorithm to do it because it's what we call super non-linear type of a problem. So, yeah.
So you mentioned that then, so around like the AI engineering techniques in terms of classic
Yeah.
robotics. So how do they sort of like differ? What are the benefits? What are the trade-offs of sort of leveraging each
Mm,
in systems like autonomous cars and also the airplanes
yeah.
itself?
Yeah, for autonomous cars, and even as a lot of these companies, Boeing and Airbus, are working their way towards autonomous commercial flight, classical controls give you certain guarantees about the performance of the aircraft and also limit the performance of an aircraft. So
Mhm.
one of the things that can happen in flight is you're flying along and then you can trip an alpha, basically an angle of attack limit, and you stall the aircraft and just fall out of the sky. You don't want that to happen. And
No.
classical controls can almost guarantee that that won't happen if you build your control laws correctly. What happens is if you try to use a neural network to do that, you can't ever guarantee that you won't stall your aircraft and fall out of the sky. You can have high statistical guarantees that you think you might not, but you can't ever actually mathematically guarantee it, where you can with optimization. For AI, for the decision making portion, classical controls don't do a whole lot of decision making. They're more of like, let me do a loop to make sure I'm in a good state and just keep doing that over and over and over again. So when you layer AI on top of it, doesn't solve the whole problem, but it allows you to make some really interesting decisions that you probably couldn't have made,
Mhm.
prior to incorporating it. So, when to go left, when to go right, when to stay out of national certain airspaces, when to communicate your status to other aircraft. There's so many different variables that go into an autonomous system. And yeah, you could write like a classic algorithm, like an if else statement to try to catch every single use case. But it may reach a point where it's actually easier just to train the algorithm, or in AI terms, let the computer learn itself how best to communicate its actions and decide what actions to take. So it's really about getting the right teams together to communicate, including modern AI scientists and classical controls engineers, to build a blended solution that helps you build things safely. So I'll give you a car example. Um, you know, Tesla got in the news a lot early on because they crashed their cars.
Yeah.
And it showed some flaws with the way that they were, leveraging particularly video cameras and computer vision to be able to detect objects. So, what has happened since then is, more of these type of companies have begun to incorporate, multiple types of sensors, including like, sonar and things for up close range and radar, so that you have a little bit more of guarantee that, something's going to be in front of you. And then you build a classical control algorithm that just says stop the vehicle if you're going to, reach some threshold of brake range, which is a little bit better than trying to detect an object and then translate that into 3D space as to where it's at with computer vision, and then hope you're right on a sunny day and a dark day and in rain and all this different stuff. So
And that's the same with sort of the Waymo cars as well, because again, as you know, Cruise also they've had their cars pulled.
yep, exactly. Automatic adaptive cruise control, those algorithms are pretty well understood. And have been around for a long time. Deep reinforcement learning has been around for a long time, but the compute power has not been there until recent years to be able to exploit it. And so we're really working through finding the right blend of combining them right now.
Right. So how do you sort of figure out the correct blend when it comes to sort of human oversight to blend like the sort of the control and the autonomy around there? Like how do you know like
Yeah.
what input to have there?
There's sort of a mathematical answer to it, but there's also sort of a team answer. What you'll find often is that modern AI scientists come out without any understanding of classical controls. And they'll be like, well, let's run the algorithms and simulation over and over and over again and prove to ourselves that we think the reliability meets some standard. That's an acceptable answer to some degree, but also like in the real world, that's continuous versus a discrete simulation. You have all kinds of variables you can't account for. So the robustness of the algorithms aren't that great. And then, classical controls algorithms often don't know modern, AI techniques. So they want to be completely closed off to it and think of it as just this classical feedback loop control problem, which works for some things. But then, classical controls isn't necessarily going to help you, navigate,
Mhm.
some sort of a city grid where you're trying to get the car to drive itself around at a higher level. So the mathematical or kind of philosophical engineering approach lends itself, at least in my opinion, to where you have high decision space, where you have to make a lot of decisions. You want to use modern AI. Where you want to control the vehicle, it's better to use classical controls because you have a little bit more guarantees on being able to brake appropriately with an anti-lock braking system, and then also adaptive cruise control to make sure you stay a certain distance behind the car in front of you relative to your energy. I think
Right.
it's a very natural progression.
Hmm. Got it. Okay. So, how would you say the systems have progressed over time when it comes to sort of advancing AI and autonomous robotic systems? So, you said obviously it's been around for a while in terms of deep reinforcement learning of those
Yeah.
cars, but how would you say they've progressed?
Yeah. Really, it's been compute power has enabled the interest in the technology, which has then enabled the deep reinforcement learning algorithms and machine learning algorithms to become more mature.
Hmm.
So it all kind of started with the hardware. As hardware started to increase rapidly, we're like, hey, GPUs are really good for this type of technique that we've known a lot about for a long time, where computers can kind of train themselves. And you're like, okay, that's good to know. Now the computer algorithms are kind of behind because we, haven't really thought about, or we haven't spent a lot of time trying to mature them for large scale, neurons and neural networks because we didn't have the compute power before. So it wasn't worth thinking about. And so a lot of research has happened over like the last 10 to 15 years into how we design neural networks, at a mathematical level for like, ones that have thousands of neurons in them that are all interconnected in some way, which has allowed us to kind of exploit the AI side of the tech space. But then we kind of went like, we got all hyped up on it and we were like, AI, 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 AI. And we, went hard on computer
Yeah.
vision and all of these things, and kind of forgot about the classic engineering techniques, which were used for a long time to fly airplanes, to drive cars, to like, handle large manufacturing facilities that were automated, all that kind of stuff. And now you're seeing them kind of reconverge together where there's like these multidisciplinary teams that are coming together and AI is doing what it's really good at, and controls are doing what they're really good at. I will also say that I think we're on the next step of another hype curve where instead of like computer vision training, we are now in the large language learning model, like generative AI space.
Mhm.
Since that has come about in the last couple of years in terms of popularity, now
Yeah.
everyone's kind of on the hype curve. And I think at some point we'll have a question of like, what is that really good at doing and what is it maybe not so good at doing, like giving safe answers to kids who are typing things in the chat gpt, or like generating code without a human actually looking at what code was generated. I
Mhm.
think at some point we will have to figure out the right blend of classical approaches, peer reviewed code, with like what chat gpt is capable of generating essentially.
Yeah. Okay. Oh, that's what I was going to ask you at the end. Is sort of like, what sort of breakthroughs are you going to see on the horizon? Is there anything else that you see? Obviously, we're talking about generative AI in terms of that's like the buzzword in terms of
Yeah.
everyone's discussion AI. What do you think is going to happen beyond that as well?
I actually like I'm starting to see it in the space a little bit and I'm really excited about it on a practical level. People are starting to combine large language models with some of the robotic system techniques that we've been maturing for many years, in a way that is allowing humans to speak in natural language what they want with a robotic system, and then
That's
the robotic system to be able to do it and communicate back. So if you think of like a Tesla bot, which may come out, which might be like a home robot, it would
mm,
be amazing if it had large language models incorporated, because then I could kind of speak to it like a human and say, rather than, it has like three things I can have it do, I can just say like, hey, could you like walk to the fridge and like, go get this thing or make me a meal or clean the dishes generically, however best you think it should be cleaned. More like a human.
they had that, didn't they? The interview with the UN. I don't know if you saw it, but there was like robots talking there, and they actually were just running it with just robots.
Yeah. Yeah, I think there's some really neat technology coming out all across the intersection of those two spaces, robotics and large language models.
Yeah,
So,
it's pretty scary, but also cool at the same time. But
yeah,
yeah,
same.
we'll have to see
Yeah.
what happens.
Yeah,
Yeah.
hopefully we do well as a society to incorporate, safe enough policies that we don't trap ourselves into a Terminator type of situation. To be clear, I don't think that's going to happen.
Okay.
But there are considerations that we may not be aware of. We learn things about the safety of systems all the time, and what if there's some unintended effect of my AI that I wasn't anticipating?
Mm.
Um, Maybe it gives me a wrong medical answer and I treat a patient incorrectly. That I was a little bit too lazy as a doctor and I didn't think about what kind of interference might be in this medication. And I didn't tell the large language model ahead of time and it didn't know. And now the patient's in a bad spot. I think things like that are real concerns that we
Yeah.
should look out for as a
Sure.
society.
People's lives. So, what
Yeah.
else do you think would be other ethical considerations when it comes to developing and deploying these sorts of technologies?
Yeah. In the defense space, there's definitely ethical considerations around how much of the mission you give up to allow an AI to do. We often talk about in the defense space, the kill chain or an authority to make some sort of a decision to take someone's life, which is like a heavy decision that a commander may have to make in some area of responsibility in some future war we're in. The question is, how much of that responsibility do you give up to give to an AI? And
Hmm.
currently there's policies in the DoD, but I think that those policies were built with a legacy view in mind, and they probably need to be updated. I don't think I'm qualified to say what the policy should be, but that's going to be, a tricky piece that we need to look out for as at least a U.S. defense nation, and UK and other allied partners with the U.S. as we start to mature these systems that have real capabilities to be, dangerous on the battlefield. Um, but yeah, that's an example.
Hmm. So, just last but not least, for in terms of us wrapping up, so what sort of advice would you give to sort of aspiring engineers who are sort of interested in the autonomous systems and AI space as they sort of embark on their journey?
Yeah, it's a really exciting space to get into, and you don't just have to, have a degree to get into it. There are a lot of people who don't have a degree who are just, learning how to program online, reading Wikipedia articles, reading other articles that are out there until they come up to speed, and then, prototyping themselves. OpenAI Gym is a great example of like an open community that's, teaching people every day to do, basic artificial intelligence and programming, and there are really cheap robots out there and quadcopters out there you can get on Amazon right now and start to do your own thing to get into the space. So some of the best engineers come out of just prototyping themselves and learning how to learn.
Yeah, I feel like that we definitely need more of those people, don't we? So
Yeah,
hence why you guys
absolutely.
come to recruitment agencies. But no, I think the more we can have
Yeah,
these people, the more it's going to
100%.
positively impact our society.
Work with Malika after
Yeah,
you've done
exactly.
that a little bit, and
Exactly. Anyway, well,
yeah,
great to have you on here, Ron. Thank you so much. This was super insightful, and yeah, just a really interesting space for you working in there as well.
awesome. Thank you so much, Malika. Really appreciate your time.
All right, thank you.